So, und jetzt begrüßt bitte Rainer, ein Informatiker, ein Philosoph, der mit uns darüber reden wird, was die Informatik nicht kann.
Okay, we have the sound back.
Ja, herzlichen Dank für diese konzise Einführung. Genau, ich will heute sprechen über die göttliche Informatik. Man kann das Göttliche natürlich auch an Gänsefüßchen stellen. Das ist so ein bisschen ein Experiment, wo ich so ein paar Sachen mal zusammenbringen will. Wenn ihr nach dem Talk rausgeht und sagt, die eine Hälfte wusste ich schon und bei der anderen Hälfte war alles komplett falsch, aber diesen einen Gedanken, den fand ich spannend, dann habe ich meine Mission heute erfüllt. Werden wir mal sehen, wie wir das hinkriegen. Ich finde es immer ganz wichtig zu wissen, wenn man jemanden hat, der da vorne steht, zu wissen, aus welcher Position er spricht, besonders weil wir
we have audio problems and we're going to find a laptop and start the stream and I'll translate from the stream and so will Niels, by the way. Welcome to this talk. As much as we can translate of it, it's about divine computer science, and your translators are Sebalis and Ningbi, and we're trying to get the stream started as soon as we can.
Für Informatik und bei Amnesty International, das so als vorneweg Disclaimer. Ich spreche aber jetzt quasi für niemanden da. Selber, ich habe halt Philosophie studiert, habe so ein bisschen Philosophie der Wissenschaft gemacht, Sprachphilosophie, Philosophy of Mind, habe mich dann in die politische Philosophie begeben, habe dann mich mit Informatik beschäftigt, habe gemerkt, ach, sehr interessant, da gibt es ganz schön viele Überschneidungen und habe jetzt einfach mal das Zitat, was hier auch am Eingang des Saals steht, rangeworfen: Computer science is no more about computers than astronomy is about telescopes. Das heißt, der Computer ist an der Stelle eben ein Werkzeug, um Dinge zu tun, und dieses Werkzeug hat bestimmte Eigenschaften. Und diese Eigenschaften sorgen dafür, dass man es auf bestimmte Arten verwenden kann und auf andere Arten wiederum nicht. Ich will mal auch noch darauf hinweisen, dass insbesondere Ada Lovelace im 18. Jahrhundert, kann man so einordnen, Charles Babbage, die Difference Engine, beim Übersetzen einer mathematischen Maschine an der Stelle schon überlegt hat, wenn wir mit mathematischen Konstruktionen irgendwie Objekte aus der Realwelt darstellen könnten, dann könnte man ja auch, wenn die Maschine mathematisch auf diesen Zahlen rechnet, könnte man ja auch irgendwie Objekte verarbeiten inhaltlicher Art. Also es war meine eigene Literaturrecherche her so eins der ersten Überlegungen, wie man quasi mit Computern nicht nur rechnen, sondern auch Sachverhalte irgendwie bearbeiten kann. Ja, meine aktuelle Ausgangslage ist, dass die Informatik für Wünsche und Sehnsüchte nach einfachen Lösungen gerade herhalten muss. Und ich als Informatiker bin da so ein bisschen kritisch, welche Wünsche da herangetragen werden und auch welche Kolleginnen und Kollegen aus meiner Zunft auch aktiv daran mitarbeiten, diese Wünsche aufrechtzuerhalten. Man kann auch noch sagen, bei der göttlichen Informatik ist vielleicht ein bisschen vorgegriffen, aber die Mathematik und die Physik und die Biologie, die haben das alles schon durch, was die Informatik gerade so durchlebt. Gerade in der Physik erinnert sich vielleicht der eine und die andere so an Bildern, so wo gerade das nukleare Zeitalter ausgerufen wurde und selbst der Herd in der Küche wurde mit kleinen Nuklearreaktoren betrieben und sozusagen das war so ein bisschen die Idee. Sozusagen, da war dann alles nuklear und das Nukleare war sozusagen die Lösung für alle Probleme. Jetzt sprechen wir eben über das Internet, künstliche Intelligenz, Blockchain und so weiter. Ich habe das mal als Informatik so ein bisschen zusammengefasst. Der Vortrag soll bestimmte Denkweisen explizieren. Wie gesagt, wenn ihr sozusagen protestiert, dann protestiert, also ich würde ungern mit sozusagen brennenden Holzscheiten aus dem Haus gejagt werden.
So investigations are continuing as to why the sound has dropped. It's apparently the mixing board for the whole room upstairs that has to be checked, and then our switchboards here in the translators' cabins. And we're trying to get an alternative source going, and we'll translate from that.
Dann gibt es einen kleinen...
So now we're talking about the internet, artificial intelligence, the blockchain and whatnot.
This talk is going to make clear some thoughts. So please don't, run me out of this building with pitchforks. I'd like to point out some alternative modes of thought. And yeah, so I'm gonna try to navigate this topic the way I see it. So with quick steps, we're going to go through computer science, and then we're going to talk about ideas and images of the world and of human people. Then we're going to talk about economies, about unholy alliances, and the role that politics plays within all of that. And then some literature for, further interest in this topic. So computer science, well, the basic of computer science is the computer, the universal machine. It's not the technical device necessarily, but it's a Turing machine that can emulate other machines. And so you write software, for example, algorithms that define certain heuristics. So computer science is interesting because this sort of science, after it built all of those structures, it says, oh, this is interesting, how does this work? How, we have networks that scale, and we have black box testing as though we wouldn't know what we've built. So this is some sort of, mesh science that doesn't actually know about itself all too well. So this is part of computer science, as well as reflecting its own theoretical base. So there's theoretical computer science, effectivity, data structures, what can be computed, what sort of claims can be made about applications, what can we say about programs, but also this theoretical aspect also contains the social effects of computers. And so within computer science, there's always this figure of the freak, someone who reads books and, is always like, don't do databases like this, just think about the consequences and everything. And so the promise that computer science makes is always that well-put problems can be solved by computers, and then the results will get better and better using computers. And the products that at the end come out of that, on the other side, I'm not going to talk about this whole, knowledge, this scientific approach, well, maybe a little bit. These products, they're tools for all different sorts of applications. For example, image processing up to AlphaGo. Autonomous cars, Facebook bots, and the basis of social scoring that we've already heard about today. And also climate simulations and emission testing. That's all sort of connected. It's, that's the sort of bandwidth we're talking about here. And so our current modes of operation that I want to talk about today, it's not very technical. It's like machine learning, trustless databases, blockchain, can we have smart contracts, cryptocurrencies and whatnot, and voting. The question that, I want to deal with in this talk are the models that computer science uses and then applies their tools to do with these models. So what gets modeled and what are the limits of said modelation. So I want to talk about the limits of computer science. And then a further question is the application of those tools, and then we need to talk about decontextualizing and recontextualizing. We're talking about technical systems that have inputs and outputs, and
of course, we can have phone calls together in some sort of club and record them. And, for example, we can measure time within a sprint and then use that information in all sorts of different contexts. But, of course, the application is very important. So, for example, a police database, that's a prominent example. So there was a database in Germany called politically motivated left, and so the data privacy person back then, he was concerned with that, and there was two viewpoints. So the security agencies, they've thought that, if there are people protesting nuclear power, they're already a danger to the state. But different people, put different models to these databases. And so the data itself, through all of these different use cases, could get us quite different outputs. So, for example, the Jew registry in the Netherlands, when the Nazis came, they were like, oh yeah, thank you very much for preparing all of this data for us. So for example, funny story actually, the introduction of SAP software, they always say that 3 computer scientists get sent there, and then 30 advisors go to the company to restructure the company so it fits the software. So again, recontextualizing. So the question again is, how do we build models, and what sort of systems do we build? And now to part 2, how do we view the world and how do we view humans? So I've said that, computer science is about, modeling objects, modeling simple states, so a computer can deal with it. And so basically we have 2 problems with that. Mathematical modelation of, for example, an image. How do we get the pixel values, the color values, how do we get the information how do we get information that is processable? And so maybe the core of all of this is abstraction of distinctive features. So, for example, I want to build a system that models friendships, human behavior, human relationships. So what is a human person? What is friendship? How can they connect with each other? And, for example, are there only like 2 genders available for choosing? And or is it, is it a free input field? So all of that affects how people use a certain system.
Ethnologists in Papua New Guinea going to people asking questions about their cottages and questions like, what can you see on this photo? The size doesn't matter. The response is, no idea, we don't know. But, well, that is your cottage, isn't it? But my cottage isn't as shiny as that, it's out of wood. And they went on to the next person asking things like, what does this picture tell you? Does that tell you anything? The size and the material should not matter. And the response then was, well, still we don't know. And confronted with the statement that this is your cottage, the response was, well, I can't go into it, so it can't be my cottage. So you can take this further and say the realization was that the example of natural depiction was clear to those ethnologists because they knew what was relevant and what was not. Size in a photo is not relevant. The material is not either. But what is important? How many windows are there? Color is important. Things like that. So instead, in the place of in this place, it's not so simple to really find an appropriate model. There are many aspects linked to it, and the modeling is quite decisive. And the question, what is interesting and what's not, or relevant, that objectivity simply isn't there. It's not objectively clear what is to be considered relevant. Although in computer scientific systems, that is often quite well defined. The second pointer or thought about how you build models of the world to then process these models is a nice thought experiment from the colorblind, about the colorblind neurobiologist. Now, if this neurobiologist knows everything about the brain, what does she know about the perception of red if she is colorblind herself? So how can you model facts or relationships that you don't know about yourself? And that is quite important for systems that you build, and that might be used in different cultural contexts. So the thing is, this shift of meaning or shift of aspects that we want to process and that we don't want to process towards models that a computer, a universal machine could handle is a very difficult one. And the terms we use in computer science itself are the machine learns, or she knows something, or it has recognized a symbol, or that football, or it thinks, it is thinking, if the spinning symbol is shown. These systems decide something, they feel something, and that is something you have to be very careful with for the reasons that I've just talked about. Now, this all sounds very soft and vague, and then the question is, what do we all make of all this? And there are 2 or 3 current trends that are very clear with their answers to these questions, and that is why I'm calling this divine computer science. One is the transhumanism. I'm just briefly going to touch upon that. Transhumanism has very clear answers. We just hack everything into the system and then say faster is better, longer life is better, and more memory or remembering more is better. So not what is the cottage made of, but we simply define this. Everyone wants to live longer. Everyone wants to memorize or remember more. So this human improvement, that of course is the question you have to pose. Isn't really there anymore. The question what is better isn't really there anymore. But a lot is lost that way also. Then artificial intelligence. I will not distinguish between general or domain-specific AI has answers to those modeling questions, which are quite interesting too. One is, well, human is an information machine and everything is quantifiable information with a certain finite resolution, and all aspects of human lives are computable. So it's kind of from the other way around, from behind, you get to the statement that everything that we can model in a quantifiable way, or the other way around, the world ultimately consists of this information, so everything is quantifiable, and what's quantifiable is mathematically modelable, if that's a word. So there's nothing really that does not fit in. So these questions are just choices between A, B, and C, but it's no real decision at this point. And these viewpoints both kind of taste like cybernetics, perhaps, that one or the other of you will still have in mind, and that had statements like the whole world consists of control circuits, and there was that slogan of mathematizing biology. You would hear, well, we all know a thermostat at the radiator. You set a certain temperature, and the thermostat will open and close depending on the room temperature, so it will approach some kind of equilibrium. And this image was then going to be used for the human circuit as well, and for human thinking as well. And you realize at this point that it goes in a somewhat similar direction to those other approaches that I talked about. But there have not been any satisfactory consequences coming from this, because ultimately the interesting results would have come at a point where the real world would have been too complex to be modeled with these circuits. And that means because that at this point, totalitarian approaches, remember, everything is information, everything is describable. These are totalitarian approaches to modeling that seem to provide a closed answer, a final answer, and everyone that contradicts those are just simply non-believers or not yet believers. So what they have in common is the reduction to what is computable, and what is computable is then supposed to be real and processable, and everything else is simply ignored or simply does not exist. And then, of course, you have to take care of the difference between computability and precision. You can be very precise but calculate the wrong thing. So if you have an example, a result that is exact to 15 digits behind the decimal points, it could be completely wrong still. So these totalitarian approaches, mostly, in the last consequence, the example they use to model human reality is physics. Which is basically a collection of particles which you can model, and that is the ultimately valid model of everything, and that you could model in a computing machine. So as a kind of interesting piece, let me just point to the free-body problem where you do not have computability. What these approaches have in common, approaches that are very widespread, particularly in the technological community, is the reduction. That's what they have in common. Not in the sense of we have a complex world or complex state of things and we project that onto models and then keep computing with these models. But what I'm talking about here is the information of the facts themselves before they are mapped into the model. So an unconscious ignoring of things that are beyond what we are talking about, which I would call a data fetish, because the things that you model are ultimately mappable into data, and the complexity is then further reduced by saying that, well, if you have an informational and technological system and use it between friends or in society, then it doesn't quite fit into these models with which you want to work, because often the society is defined as a set of individuals all for themselves, and then it fit into models. So, and then, of course, Ayn Rand with objectivism is knocking at the door, and this mixing, it may sound a bit vague and floating, but you can boil it down to more data means more knowledge. To have more data and link more information that you can access, with which you can deal as a human. Data is then a syntactical existence. And at this point, to have more data is, of course, an end in itself now, because you feed the system that way and combine things. And if you have various approaches of thought, I don't know who of you will then say, well, okay, I do see it that way. The world does consist of well-definable information. Now, please, hands up everyone who believes that ultimately everything is defined informational structure and there's nothing else there. Okay. The courageous ones have shown up, of those that believe it. I mean, thanks very much anyway. And between these reduced data objects, as I see them, the context of human use is kind of losing color. If you consider an old fairy tale about a village society, the way these people interact and the symbols that are exchanged to define group membership and things like that you can interpret in different ways. And well, you can more or less reduce it further to what the robotist Horashi Ishiguro said. He said that when he builds his robots, if he is at home, he is so tired once he gets home from that, he'll just watch TV, and that, of course, a robot could do for me. Because for the children, it doesn't matter whether I or a robot is not playing with them. I'm not going to say that this automatically fits together, but if a worldview or a world model looks that way, then of course it becomes very simple. The world image, that is something that is very easy to model and build a computer that processes it. And I am also not talking, as I was alluding to in the introduction, which we probably missed as translators because the sound was gone. Now, these purely philosophical thoughts and this technology belief is spreading rapidly. The Singularity University in Silicon Valley churns out a class of well-funded, brainwashed entrepreneurs each year to build the technologies needed for the transhumanistic vision, Sarah Spiekermann. So there is a lot of money involved. And these kinds of thinking, kinds of thought approaches are well monetized and put into existing software system, which then unfold their effect on society. Now, to put it in a less drastic way and a less critical example, I'm kind of jumping ahead with the context now to show you the parallels. The blockchain technology as a concrete technology calls itself a trustless ledger. So it is a general database that anyone could look at, and there is no central authority involved that you have to trust. And currently, it seems to be the solution for just everything and anything from Microsoft up to banks. Everyone is doing research on it and says we could use it for election system, currency, smart contracts, markets. What I found very nice was this little chart here where you can think what you want to do, is blockchain something useful for that, or is it just something you could deal with a normal database? For the so these flowcharts were funny, because that brings me back to the earlier point. The interesting question, of course, at this point is to be able to work with the blockchain in a reasonable way and to really distribute that trust. You have to make sure that the people that work with that blockchain are more or less similar in computing power, as we see with Bitcoin at the moment. If one company in one country, for example, simply buys so many strong systems, they can then determine what the future for that system should be, and that, of course, is no longer decentralized. So the question is, has the trust simply shifted outside of the technological view through that technology and now located elsewhere? This trustless ledger refers to the technology, but which other actors do you have to trust in what ways? So that is outside the technological view, but it's not gone completely. And so the question is, who controls the machines and how strong are they? All right.
All right. So now an outlook on business. So yeah, a few people in the room might not like this, but I'm going to talk about neoliberalism for a change. Yeah, nice introduction, right? In the last century, there was a fight between various modes of economies. And so communism, liberalism, I'm going to pick neoliberalism and point out why. So we have the Chicago Boys in Chile during Pinochet's rule, and then Thatcher in the UK starting in the 70s after Bretton Woods. And, monetary value wasn't bound to the gold standard anymore. And so what I mean by this is austerity and privatization as modes of this economic model, and the subsummation of all sorts of areas of life under this economic rule. And so we have individualization, for example, and psychological influences. So we have game theory, rational choice approaches. So there's inputs that make a human being do something, and there's always rational choices that these human beings come up with to produce a certain output. And so you can already see that there are certain parallels in this mode of thought, how we can influence human behavior. And so examples out of Chile, but this trend spread globally throughout the 80s, this understanding of economies and governance. So Chile was some sort of laboratory for neoliberalism. It was privatization of the health insurance system, privatization of retirement funds, privatization of the school system. In Chile, they made it a lot harder. They even outlawed workers' unions, and so the idea was to get more investments into the country. But the result was that the economic output of the country rose a little bit, but the middle class was reduced. There was a growing gap between poor and rich, growing number of people out of work. We can, of course, talk about what that means. Degradation of the overall level of people's health. And we can also see this sort of development in Germany. And a lot more in other countries. So maybe, as an aside, this is way more important in the UK and the US, because in the last few years we can see, Jeremy Corbyn, Bernie Sanders, very left-wing people sort of raising resistance to this sort of neoliberalism. So there's this unholy alliance. What am I talking about here? We have these very, simple world views that I've talked about so far. Easy solutions to complex questions, but if these ideas meet a state that doesn't have a lot of finances to hand out, after all of these neoliberalism reductions, now we have these sort of data solutions, that promise quick solutions. So, for example, the world's most popular and the world's most biggest room rental service and taxi service, they don't even own any rooms, they don't even own any cars. So, all of this can't be wrong, right? Well, these economic constraints that I've talked about, they sort of really fit this computer science mode of thought, these simplistic models, these simplistic worldviews, and so a little, we could also call this the Silicon Valley ideology. and we can sell products better if we also sell a positive outlook on the world. That's something Harley Davidson once said. And so, there's this digital revolution right now. That's what they say. The old world is gone, so disrupt everything now, parentheses, also the social state. So that raises the question, a better place, the world gets better, but how exactly and for whom? And what's the relation to state spending with that? So we don't just want to build computational systems. We also want to have this sort of, pathos, this emphasis on making the world a better place. So this question sort of leads us to, if we want to have a better world, this raises a very important question. How do we want to live? So as some sort of heresy, if we ask Silicon Valley, how do we want to reserve a table at a restaurant? How do we want to deal with that? Also raises the question of how do we want to deal with hunger, with poverty. We still have those problems, and how, yeah. So at least with hunger, it's this app.
Hunger and lobster, that was a little confusion there because the German words are very similar. So there is a tool fetish. The question is, which problem will fit our solution? And the perennial answer is there is an app for that. And therefore, it's not completely absurd to formulate it in this rather heretic way, because you may have heard about Überhop or Lyft Shuttle, which are taxi companies who had great ideas where we could we could have larger cars, and we would not need to have them called for. We could run them on fixed routes, and people could then join into those larger vehicles, and they could be shared. And the rest of the world thought, well, yeah, buses, right? It was a very enlightening moment when Silicon Valley suddenly invented public transport. But the funny thing is, somehow it works economically. Google, Facebook, Amazon are simply ubiquitous in our everyday life now, and startups with this worldview that I talked about are meeting strong capitalists, venture capitalists, and receive political support or business political support, and they can then carry these business models backed by a lot of finance into the world. When you then have issues like the German law coming into the picture, you will have swastikas being pixelated, but the question also, on the other hand, is what is being blocked, although it would be allowed in Germany by German law, such as nipple images. When will people demand their rights for those? But don't quote me on that, please. And the description, therefore, is, at least according to some theorists who call Silicon Valley the useful idiots, thinking that these people build interesting things, but are simply door openers for much more interesting people, like insurances or other finances. So the question then is, what remains of the disrupt ideology? So ultimately, this means that public bodies use products that were initially made for commercial use. And that is, of course, quite handy because you have a quantifiable measure for success. But the public bodies work somewhat differently. Public infrastructure, like public broadcasters, storing things at YouTube, because they don't have storage capacity, then simply have those restrictions that the commercial vendors impose. You have other things like public infrastructure, sidewalk apps being developed, health system optimized up to the improvements of care for the elderly. And that, of course, is often cheap or even free because a lot of data is generated, and the smart city becomes the city as a service. A nice quip there. Now, sometimes I believe that the politics, if that's an entity, is becoming somewhat lazy, and maybe even on a global scale, and then you may have people that say, okay, I have solutions, and everything seems to fit together, and even secret services are restricted by a certain logic, and that says the world is getting more and more dangerous and we need more data. But the people that actually work with these data and try to extract useful information, in other words, knowledge out of that, say that we are drowning in ever more data, but no one is stopping that flow. Okay, I'll continue to this. Now, with these ever stronger coupling, there are questions, because businesses that you more and more tightly integrate into the public space, these businesses, of course, have to fulfill certain criteria or properties that they do not have. They are not democratic, for one thing. They have certain internal processes and their own dynamics. For example, if Waze, a routing service, says, okay, well, there's a building site here, we'll just reroute traffic because it looks nice on the map, but then you notice these are very small residential streets that are not supposed to be used in this way, and which are not able to carry the weight of a lot of traffic. So you have certain things that public policy and self-administration would be aware of, but they do not exist in those businesses. And the question then is, who makes decisions and who has the final say? And with these, with the power of the companies, the overwhelming power of these companies, the question is, how do we deal with that? What are the consequences? And that is where the role of politics comes in. If you now return to divine computer science and ask what can computer science do, or what is it afraid of, or what are you afraid of? What are you afraid of? Then I would say, are you afraid of AI, or are you afraid of businesses that enforce their own goals through AI? So the things that I've said and that you apply to these, is control slipping out of our hands? Is it control of technology, or is it the control of organizations that use that technology? And then, of course, the whole thing fits together in a very different way, and you can think of it differently. Because, and that is where the circle somewhat closes, games or economy are something that is nice to model because it's clear what is good. You win the game or you make a profit in businesses. A/B testing, things like that. It's very easy to cover with criteria. But if you have things like social involvement, acceptance, transparency, fundamental rights, there suddenly it gets very, very difficult to say, has this been adhered to or not? It's a very complex question, or answers to these questions are very, very complex, which we see in the European Data Protection Regulation, for example. And the purpose of politics then is, of course, to have an option to make decisions and clarify responsibilities and discuss these. And it is about the systems that we use, to talk about the design of the systems that we use and not just their results. So if we say that, hang on. If we say that we want to protect the weak, then it's a very complex thing at this point to define what that actually means, what the goal is, and to then deal with that, deal with the fact that systems can become inefficient because you want to take everyone with you, because it's not all just about efficiency and profit. So that means at this point, I have to make computer scientists deal with the issue that the requirements to their systems are towards inefficiency sometimes, about distributing power, which is always there, to ensure that it's not inhuman or against society. So it's not just about if you have a position where the limits of technology are to be looked at. It's not about being hostile towards technology, but about technology serving the humans and the society. So from an IT point of view, or from a computer science point of view, we do like efficiency, but it's not the ultimate goal. And lastly, I just want to say that there are positive examples, because I largely had this large approach. Small examples, the smart city strategy in Barcelona, for example, it functions in a very participatory way. Highly participatory systems remain in the control of the people affected, and because the systems are operated by the city, there are no operational secrets, and you can look at this very easily. GNU Thaler, which I think is still at an experimental stage, it's a payment method which is anonymous. The people that makes the payment is anonymous, but the dealer that takes the payment can cryptographically prove that the payment has been made, which makes it taxable. So that is the anti-model to those cypherpunks that say we don't want any state at all, or ask the state the Freedom of Information portal where you can demand your rights. The other one is called Sue the State. So if you document what the power structures are and how you want to deal with them, that kind of reflection lowers computer science from that divine state into a very mundane but very fertile tool. Thank you. Okay, we have a quarter of an hour left for questions. If you do need to leave now, please do so quietly and try not to walk in front of the cameras. And otherwise, we have 13 minutes to stay here and think of questions. You know the game, 4 microphones, queue, and we have questions from the internet too, and we'll start directly with a question from the internet. The question is, to what extent simulation models are a basis for political decision-making?
Oh, that's a very good question. It really depends on what is modeled, what is simulated. So there's a lot of social science models that try to figure out who do I look at when there's a question from the internet. All right. So that try to model individual human people, but that for me as a computer scientist, I'd like to talk to social scientists and see what they have to say about my methods and work together with them to find adequate models for their views. And so really talk to the people that deal with these problems and not repeat their mistakes. So this might be a clue and the right way to deal with that.
Person at microphone 4, are you looking at your smartphone or are you queuing? Okay, well, I am both actually, but I can ask a question. Nerd-wise, I am a bit of an Asimov fan, and you have these 3 robot laws there. You talked about how machine logic and biological logic are not completely agreeable or compatible, and I understand. I agree. I agree with you there. I concur. But there are theoretical approaches with which psychology can be described quite well, and psychological interventions can be made. For example, in psychotherapy, organizational psychology, you can make progress there. So, in a way, the person viewed as a system of personality traits or an organization as a system of various stakeholders. So I do concur that this atomization is counterproductive for a cool societal development. So the question now, I'm looking forward to the question, says Rainer Rehak. How do you view this? And hang on. And what approaches of cybernetics in a global view of both biology and technology, which of these do you still find productive?
So what you said at the beginning, that was quite interesting, and I would have, said something even if you hadn't posed a question afterwards. But I believe the crucial point here is to always ask what effects do I hope to achieve with this model? So if we talk about psychoanalysis, psychology, and using that, that's not wrong. But what I'm talking about is this works on some level, but we don't use it everywhere. So here it's also about using certain models, but keeping in mind that we're dealing with models. And if problems arise and, we're all the time, we're in some sort of critical feedback loop, is the model still adequate for our purposes? And if it's not, then maybe it's, there might not be an adequate model to talk about the thing that we're trying to look at. And so that's the end of that totality, finally. So we can end this complex question. And regarding cybernetics, I believe I can make a general statement about that. We'd have to have some sort of, a concrete example, if I understood your question correctly, to critically reflect these requirements, and that's not some sort of one-size-fits-all answer.
Microphone number one, please. Hi. I had certain problems with your talk because I had an extreme amount of detail that you pressed into it. Philosophy, early examples, ecology, you kind of put everything in there, and I was missing the kind of main point. And to be honest, I would have hoped that you would say something about or focused on the limits of technology, of informational technology, because you said it was a mixed science that gets involved in every other science. So is it about the general limits of science as a whole? And you then talked about consciousness. Can you model that? But ultimately, isn't it about the fact that so many people are now talking about superintelligence, and these are very serious scientists that say in 25 years we'll have that. And what's the thing? What's the point about that? Aren't these the real threats that we have with this kind of talk too?
Das ist ein sehr interessanter Punkt.
Well, this is a very interesting point. So superintelligence in 25 years, that's been the case for quite a few decades by now. But yeah, I don't want to water this down, but the limits I've tried to show here, they depend on how the things we want to look at, that we want to work on, how can we model them mathematically. So if we have A/B tests, if we have click rates, we can do all of that if we want to measure that. if I want to measure customer satisfaction, then I have to critically think about if somebody clicked 5 stars. Is that really customer satisfaction? Or did I really only measure how often people click on 5 stars? Because that'll make the window go away as soon as possible on my computer. So this sort of critical distance, that for me is the limit of computer science, where we have to ask ourselves, are there decisions for what we can make, for what belongs to the model, what gets what we can model and what we can't. And so regarding your second point, so thanks for your question. That's exactly the reason why I can't find the slide right now. Okay, here it is. Why on this slide up top, it's not slide 42. So fear of AI or fear of corporations that use AI to achieve their goals. So is there, this some sort of super intelligence, but with all the knowledge I have of computers, of course there's the possibility, but right now I don't see any reasons to believe in the coming super intelligence. So I like to ask, I get the concept of superintelligence, but what are really the signs of its coming? So improvements on the hardware side, and the possibilities of AI that always grows in a linear fashion. And so people always feel that we're, just a step short of exponential growth. Also Ray Kurzweil, of course. But if people can't, provide proof, show me some signs for this being the case, I'd like to be convinced of that. But until I see any signs for that, I'm more afraid of corporations using AI to achieve their selfish goals. And so this is a political question. This is not a technical question. We've had that throughout history, slavery, child labor, until, someone politically put a stop to it.
Okay, the internet, please. Are there plans to have the most important results of cybernetics involved in a kind of polycontextual logic? Once again, please. What does to access mean? I didn't quite get that context. Are there plans to have the most important results of cybernetics involved with relation to polycontextual logic?
So I'm not really, familiar with this topic, but again, I'd say if there are adequate models to model the things that we care about, then these limits of computer science that I've talked about, it only ever applies to singular individual solutions, but we can't apply a one-size-fits-all model and expect, to have great results on all ends.
Number 4, please. Hello, and thank you for the talk. And I come from a somewhat constructivist context and ask what can actually be done, and I realized that the term power was pervasive throughout the talk, and that could mean that everyone has a feeling that they have a freedom of decision, but still a certain power is being applied. And the question therefore to you is, firstly, do you know any kind of views of information technology systems from that point of view, or do you consider it a correct approach?
Das finde ich eine sehr, sehr
This is a very interesting question. In fact, there are these sort of principles. So I've named them here, right? There's small or even large projects that raise these exact questions. For example, Christian Kühner once coined the term
power, cooperative systems without power.
Without rule, yeah.
Without rule.
So this sort of distribution of power should be inscribed into hardware and software, and it shouldn't be, people, then you shouldn't be able to take this distribution out again afterwards. So that's when we use IT systems, that's something to think about. And in my opinion, within the political context, we always have to be able to understand what happens, and we always have to have the ability to influence a certain system. So maybe, well, it depends on the application, but in general, we might talk about peer-to-peer systems. That might be my first hint here. Or like Knuthaler, the example I gave, there's verification from one side, but not from the other. So yeah, there's approaches there, definitely.
Einen Applaus für Rainer, bitte.
Okay, that was it. An applause for Rainer, please. And hopefully an applause for us interpreters too. This was interesting. I hope we were able to